Okay, here's problem 7 from the review sheet. And this one says consider a club with 8 members. Calculate the number of ways for the club to choose a two-person committee first. So part A, I'm going to use the combinations formula. I have a club of 8, and I'm going to choose 2 from it. And I'm going to plug in 8 factorial all over 8 minus 2 factorial and 2 factorial. And this is 8 factorial over 6 factorial, 2 factorial. And so this is 8 times 7 times 6 factorial, all over 6 factorial times 2 times 1. And so the 6 factorials cancel, and it's 8 times 7 times 6 factorial because 8 factorial is 8, 7, 6, 5, 4, 3, 2, 1. And I just wrote the 6, 5, 4, 3, 2, 1 as 6 factorial. And so you can see these cancel. 8 times 7 is 56, divided by 2 is 28. There are 28 ways to choose a two-person committee. Now it says let's choose a 6-person committee. Well, there's a nice symmetry between the binomial coefficient C82 and C86. And watch what happens when I plug in here. I'm going to plug in 8 factorial, 8 minus 6 factorial, and 6 factorial. And again, I get the same exact number, except I get 2 factorial, 6 factorial. They're just reversed in order in the denominator. And so we get 28 again. And so it says here, explain in words why this value agrees with the number of possible two-person committees. And it says, hint, there's a bijection between the set of two-person committees and the set of 6-person committees drawn from an 8-person club. And if there exists a bijection between two sets, then those sets have the same size. Describe this bijection. Well, for every two-person committee, I'm going to associate that with a 6-person committee made up of those who weren't in the two-person committee. So if my people were labeled 1 through 8, if I had a two-person committee of persons 1 and persons 2, then that would be mapped to, in a bijection, a 6-person committee of people 3, 4, 5, 6, 7, 8. And since we have that bijection, these two have the same size, the set of all 2-people committees and the set of all 6-people committees. For part C, it says to calculate the number of possible ways for the club to choose a president and a vice president. And for that, I'm going to use the permutations formula. Try to stop this thing from vibrating. So, to a president and a vice president, so I'm choosing 2 out of 8. And the permutations formula has n factorial and then n minus k factorial. And you'll see, this is 8 times 7. Well, let's just write 8 factorial. What am I doing? 8 minus 2 factorial. So this is 8 factorial over 6 factorial, which is 8 times 7 times 6 factorial all over 6 factorial. 6 factorials cancel and I get 56, which is twice as the number of the 28. And that makes sense because when I choose a president and a vice president, it's like choosing a two-person committee, but there are 2 ways of doing it for each of the committees. Remember, in the committee, the order didn't matter, but when we choose a president and a vice president, the order does. So if I have a committee of, elements 1 and 2, that corresponds to 2 different ways of choosing president and vice president. Element 1 could be the president, 2 could be the vice president, or vice versa. So the number is 56. You can also calculate this number by using the counting principle. You say we have 8 choices for the president, and when we're done choosing the president, we only have 7 choices for the vice president. Okay? So either way. And that's how I derived the formula for the permutations in the first place. Part D says, let's see, I hope I have room for it here. Part D says, calculate the number of possible ways to choose a president, vice president, and a 3-person committee where the president and the vice president cannot be on the committee. Well, I'm going to do this in 2 steps, and I'm going to multiply the ways that they can do it. And so the number of ways is, first I'm going to choose the president and the vice president. So I'm going to choose P8, 2. And I'm going to multiply that by the number of ways of choosing a 3-person committee out of those committee members that are left. And how many are left? First of all, it's combinations because it's a committee. There's only 6 left after I choose the president and the vice president, and I'm going to choose 3 from that. And I can figure this out. This is 8 factorial over 6 factorial. C63 is 6 factorial over 3 factorial, 3 factorial. And you can plug in carefully the way I did up here to verify these numbers. And I get 8 times 7 times 6 times 5. Let's see, the 6 factorials cancel directly. Times 4 times 3 factorial. And I have 3 times 2 times 1 times 3 factorial in the denominator, so these cancel. And the 3 times 2 times 1 cancels with the 6. And I'm left with 8 times 7 times 5 times 4, which is 20 times 56. Double 56 is 112, so this is 1120 ways, I believe. You can check that calculation on your calculator. Okay, so this is part D. I'll note that an alternate way of doing part D is to first choose the committee. I'm going to choose the committee of 3 out of 8. And then second, I'm going to choose the president and vice president from the remaining 5, so P5, 2. And if you do this, it will match up with the answer I already derived for D. So I hope that helps. Hope the shaking video camera isn't too obnoxious here. Sorry about it.